blending. So I'm on section 10.14. So this is section 10.14, and it's called blending and dilution calculations. Okay. So what this means is that if I want to say dilute, so let's just first talk about dilution. What I mean by dilution is, so say if I get a 4% polymer solution, and in the plant I want to use it, but I cannot use it until I make it down to 0.25% polymer solution. Okay, so this is what I get from the vendor. This is what is the concentration that I want to use at, mainly because this 4% say is very thick and I can't just add it to my process. So I have to make it dilute it down in another tank to down to 0.25%. And then after I make it 0.25%, I would add it to my process. So the question is, so this basically, this dilution calculation allows you to say, okay, how much do you need to dilute this 4% solution to get a 0.25% solution? So the question will come like this. So say if I have, I'll just make it up from here. So I have a 4% polymer solution. And I want to make 5,000 gallons of 0.25% polymer solution. So just bear with me, and you'll get it. So and I'll have to draw a sketch for me to explain to you exactly what I mean by the dilution and all. So make 5,000 gallons of 0.25% polymer solution. How many gallons of 4% polymer solution is needed? That is the question, and I'll explain to you. So don't sweat over if you don't follow what I'm saying. So basically what I'm saying is that I have a tank, right? And in this tank, I'm going to make 5,000 gallons of 0.25% polymer solution. That's what I want to make, right? And the question is, so in order for me to make this 5,000 gallons, so say this is the 5,000 gallon mark in the tank, right? So basically, if I want to make 5,000 gallons of this 0.25% polymer, I will have to add initially a certain quantity or a certain volume of 4% solution. And then basically what I would do is whatever exact volume that I need, I would add it to the tank. Sorry. And then what I would do is I fill the tank up to this 5,000 gallon mark and then mix it. And then that becomes my 5,000 gallons of 0.25% polymer solution. We have a certain higher concentration of the chemical, and you want to dilute it down to a certain percentage, but you know how much volume you want to make of that diluted polymer. And the question is how much volume you are going to take for this 4% in order to make this 5,000 gallons of the solution. So basically, the formula there is C1 V1, and I'll explain everything, is equal to C2 V2. Okay? So what the C1 is, C1 say is on this side, the 1 is the 4%, and on this side, the 2s are the 0.25%, right? So basically, C1 is 4%, so C is 4, and volume is basically what I want to find out, right? How much of volume do I need? That is what I want to find out. And that is going to equal to C2, which is 0.25, multiplied by the V2, which is 5,000. Right? Make sense? So my V1 is going to equal to 0.25 multiplied by 5,000 divided by 4. So this is 1,250, and 1,250 times 25, 0.25. So 1,250 and 0.25 multiply is going to give me, so my V1 is equal to 312.5. So basically what that means is that I'll take 312.5 gallons of the 4% solution and then add enough water to make it into 5,000 gallons. And that is going to give me the 0.25% polymer solution. Does that make sense?
Yeah.
So the reason why we do C1, V1 is this, and this is not required, but the whole rationale is, what is C? C is the concentration, right? So if I have C times V, C is the concentration. What is the unit of concentration? Concentration is always expressed in terms like milligrams per liter. Basically what it is it is mass per volume. That's what concentration is, right? So my C is mass over volume, and then I'm multiplying it by what? I'm multiplying it by the volume, right? Because C times V, right? Okay, so my volumes cancel out. So basically what I'm saying is that the mass of the polymer that I put in with this 4% solution essentially will remain the same in this mass of this 5,000 gallons of that dilute polymer. Mass will not change because I'm just adding water to dilute it after I have taken that initial mass or quantity of that 4% solution. All I'm doing is adding water to it. So I'm not adding any more mass of polymer. So that's why this mass C1 V1 is basically the mass that I put in that 4% polymer solution is going to equal to C2V2, which is going to be the mass of polymer in the 0.25% solution. Does that make sense? Because the mass is going to remain the same. It's not going to disappear. So that's the whole basis for C1V1 is equal to C2V2. That's all it is. So what you're doing is, so anytime you have any dilution kind of a problem, you basically use the C1V1 times is equal to C2V2. And the units here do not matter as long as the units are kept consistent on both sides. So if this volume, so say if this is in percentage, right? And as long as this is in percentage, it's fine. If this is in gallons, this will need to be in gallons. Do you understand what I'm saying? So the units, as long as they are the same, you're fine. You don't need to convert. It means I don't need to convert 4 into milligrams per liter or 0.25% into milligrams per liter. As long as the units are consistent on both sides, whether it's in percentage or milligrams per liter, you're fine. And of course, the volume units also will be the same.